Hi, in this video, we're going to start working with something called rational expressions, and we're going to find where they're undefined. Now, a rational expression is a fraction formed by two polynomials. So we are used to regular fractions, and a regular fraction would be like 2/5, right? But a rational expression is going to have like x squared plus 5x minus 2 in the numerator, and then x minus 4 in the denominator. So this is what we're going to start working with. We're going to be working with fractions with polynomials, and that's just called a rational expression. Now, a fraction or a rational expression is undefined when the denominator is equal to 0. The reason for that is because we can't divide by 0, right? So any value that makes the denominator 0, we call it undefined. And we're going to say that these x values that make the denominator 0 are known as excluded values. So, for example, if you were to have 1 over x, if we had x equals 0, that would then give me 1 over 0. And that allows us to divide by 0, so we would say that x makes a fraction, x equals 0 makes a fraction undefined, and we would say our excluded value would be x equals 0. In fact, if you take a look at this graph, if you put 1 over x in the calculator, graph it, and let's take a look at what's happening. Because x is not allowed to be equal to 0, we're going to see that the function doesn't even touch it. On the left-hand side, my function goes down and doesn't get close to 0 at all. And on the right-hand side, my function goes up, and it will not touch x is equal to 0. In this case, we kind of have a wall forming, a wall that we can't touch at x is equal to 0, and this is called an asymptote. We don't have to know too much about that yet, but for now, anytime they're asking which values make the expression undefined, we're just taking the denominator and setting it equal to 0. In fact, I don't even care what the numerator is. I only care when is my denominator equal to 0 because we can't divide by 0. So we take the denominator, we set it equal to 0, and we solve. If you were to solve for x plus 5 equals 0, we get that x is equal to negative 5. Now, we don't want x to be equal to negative 5, because if you plugged in negative 5, your denominator would be 0. So instead, we say that x can't equal negative 5 because it is an excluded value. For the second one, to find when it is undefined, take your denominator, set it equal to 0, and solve. This can actually be factored with a GCF of x. So when we pull out the GCF, we're left with x times x minus 6. When we make a t-chart, we get two values. We get x is equal to 6 and x is equal to 0. So both of these numbers make the denominator 0. We can't divide by 0, so we do not want these two numbers. They become our excluded values. For number 3, when you take the denominator and set it equal to 0, if you're trying to factor something with two terms, there is no DCF here. If you could take the square root, it is balanced. If you can take the cube root, it is cubed. And in this case, you can take the square root of 9, and you can take the square root of x squared. So we're going to split it up into two parentheses. One is plus, one is minus. All you have to do is take the square root. The square root of 9 is 3, square root of x squared is x. Notice how the 9 comes first, so I put my 3 first. You now make this x plus 3 times x minus 3. When you make your t-chart, A little harder to get your solutions here. We have 3 plus x equals 0, and when we solve for 3, or rather solve for x, we get x is equal to negative 3. If you have 3 minus x is equal to 0, when you solve for x, we get x is equal to positive 3. So both 3 and negative 3 make your denominator 0. We don't want that. So we say that x cannot equal 3 or negative 3 for our answer. For number 4, if you take your denominator and set it equal to 0 to find where this fraction is undefined, you have 4 terms, so this is going to be factoring by grouping. Your GCF of the first group, 8 and 64, have 8 in common. X cubed and x squared have x squared in common. 8 divided by 8 is 1. I have 3 x's, I took 2 out, so I have 1 x left. Negative 64 divided by 8 is negative 8. I had 2 x's, I took 2 out, there are no x's left. Don't forget when factoring out of the GCF of the next group, if there's a minus in front, you better take a minus out as well. X and 8 have nothing in common, so in this case we're factoring out a negative 1. Negative x divided by negative 1 is positive x. Positive 8 divided by negative 1 is negative 8. And I know I'm doing this correctly because my parentheses match. If they don't match, then you need to start over. I'm going to take what's inside my parentheses, and then I'm going to take what's on the outside of my parentheses for my other bubble. My outsides are 8x squared and minus 1. When you make your t-chart, I should have x is equal to 8. And on the right-hand side, I have to actually solve this. I have 8x squared minus 1 equals 0. So I'm going to bring the 1 to the other side, and I get 8x squared equals 1. I divide by 8. I get x squared equals 1/8. And at this point, you would have to take the square root to get the 1/8 by itself. Just make sure when you take the square root, you include a plus or minus. So this is going to be x equals plus or minus the square root of 1/8. And it makes sense that you have a plus or minus because your degree is 3. You're supposed to have 3 answers. X equals 8 is 1, plus radical 1/8 is 2, minus 1 over radical 8. Minus the square root of 1 over radical 8 is your third answer. Now, these values make it undefined, so I'm going to say that x cannot equal any of them. So last thing for this video, let's take a look at the graph of y equals 5x over 9 minus x squared. Now we just talked about how there are 2 excluded values. X cannot equal negative 3, nor can x equal positive 3. When you look at the graph, notice all these strange things that are happening. At negative 3, your graph is really trying to avoid it. The graph doesn't actually ever hit negative 3, nor does the graph ever hit positive 3 because these are excluded values that make the denominator 0. So in this case, because we have 2 excluded values, we have 2 asymptotes. And just try to remember that asymptotes are walls, invisible walls, that your function does not pass. As a heads up, just because you have an undefined value doesn't mean your